Laboratory. The Mote SEA Show on SeaTrek.tv. Coming up next, Invertebrates, on October 29, 2019, at 9:00 a.m. Eastern Time. Mote Science Education Aquarium Show. Your host, Ross Johnston. News with Stephanie Kettle. The day's STEM expert, Greer Babbe. This program is partially supported through funding from the Rob and Melanie Walton Foundation. Thank you. The Mote SEA Show, Science, Education, Aquarium.
Good morning, everyone, and thank you so much for joining me here today. My name is Ross, and I'm coming to you live from Mote Marine Laboratory down in Sarasota, Florida. Now, I am super excited for this episode of the Mote Morning Show because just in time for Halloween, we're going to learn all about the creepy crawlies that live at the very bottom of the ocean. So today, we're going to be learning all about invertebrates. Now, I am joining you live from our aquarium and our touch pool at our aquarium. Now, here at Mote Marine Laboratory, not only are we a world-famous scientific institution, but we are also a public aquarium, which is a great relationship because our scientists in our laboratory can study the animals that we have here at our aquarium, and our guests that visit the aquarium can see science in action. Now, this is the perfect place to learn all about the science of invertebrates because right in front of me we have multiple species that can be found both near shore and offshore, and all of these animals are invertebrates. Now, before we dive any deeper, I want to point out that we had a little quiz question before the program got started. This quiz question asked, what even is an invertebrate? So, option X, an upside-down barnacle, option Y, an animal without a spine, and option Z, an animal with a spine. Now, the neat thing is that we are going to be learning more about what an invertebrate actually is, but right after we have our news segment with our PR manager, Stephanie Kettle.
News with Stephanie Kettle.
Hey everyone, it's Stephanie, and here's the news that's making waves. Are you excited about ocean conservation? Then get ready for the Youth Ocean Conservation Summit at Mote Marine Laboratory this December 7th. You'll get to hear from exciting guest speakers, learn from other students about conservation projects in their communities, and hopefully develop one of your own. Registration is now open through November 24th at www.yocs.org and is available for students ages 8 to 18. An exciting part of the Youth Ocean Conservation Summit happens the night before, Friday, December 6th at Mote Marine Laboratory. Beginning at 6 p.m., we kick off the summit with a special screening of the film The Smog of the Sea, a movie about ocean plastics. So what's going on in the world of shellfish? Mote Marine Laboratory has partnered with local high schoolers, community volunteers, and scientists to promote native shellfish restoration efforts. With the help of Sarasota Baywatch and the Florida Fish and Wildlife Conservation Commission, over 200,000 native southern hard clams were released. Mote scientists are also growing over 1 million clams to be released in the future. To encourage shellfish survival, Mote is studying over 200 feet of living seawall here in Sarasota Bay with the goal of attracting more marine life to Sarasota. The living seawall is a series of natural-looking structures designed to attract ocean animals and absorb wave action without causing erosion.
Well, I am super fortunate to be joined today to answer all of your invertebrate questions by our local invertebrate biologist, our benthic ecologist, Greer Babbe.
Good morning.
Now, I am super excited to hang out with you today because I know we're going to have a clawsome time. Now, in order to answer that earlier question about what even is an invertebrate, can you shed some light on what these animals are and what do you do?
Certainly, yeah. So invertebrates come in all kinds of different shape and sizes, and we'll go through some of those today. they all don't have a backbone, so they have lots of different ways to keep their bodies together without that spinal component. Part of my job is studying these invertebrates. So I do that in several different ways, but one of the most fun ways that I've gotten to do more recently is back looking at that living seawall that Stephanie was just showing us. I took sediment samples, so took sand from the bottom, and I dug through and looked for all of the invertebrates that live there. So we have lots of worms, we have gastropods, and bivalves. We'll go over what some of those animals are.
Well, I was about to say, you just used a lot of really awesome, really fancy science words.
Right.
So just to break down your title a little bit, benthic means bottom.
Correct.
Which is pretty great, because I know there's a lot of spineless animals that live at the bottom of the ocean. So for all of you out there that chose Z, you are correct. Just like Greer said, an invertebrate is any animal that doesn't have a backbone. But they come in lots of different shapes and sizes. So speaking of some benthic animals, can you shed some light on maybe one that you brought for us to see today?
I did bring some clams, some bivalves with me today.
Fantastic. So while Greer gets some of our animals queued up, we're going to put the next quiz question up on the screen. So we're going to learn a little bit more about bivalves. So what is a bivalve? An earthworm or a leech, a snail or a slug, or Z, a clam or a scallop. So while Greer gets all of our science together and we get to see what she does on a daily basis in her laboratory, put your answers into that chat box. Fill out that poll and let us know what you think a bivalve is. All right, I see the answers coming in. Very exciting. So it looks like the majority of you have chosen Z. Greer, is that correct?
That is correct, yes.
Fantastic. So can we meet one of your bivalves that we have today?
Absolutely. So right here in this little aquarium, I have a few of the southern quahog, Mercenaria capuchinensis, if you're interested in that scientific name. So there's 3 clams here today. Southern quahog clams is a common name.
That's awesome. Well, I think it's a pretty good reason to celebrate. Terrible. Now, clams are something that you study in your everyday work world. So why do you study them? Why are they important? What science do you do with a clam?
So clams are important for a number of reasons. They do feed other animals. We'll go into some of their predators a little bit later, but they also filter out all kinds of things in our water. So very important in terms of being a water filter.
Cool, so they clean water. Now,
yes.
Your water looks pretty clean, so can we test this theory? All you ocean science out there, do you want to see some science in action? Is that a way? Can we see some science in action?
Absolutely.
All right, so I'm going to grab our bucket of science right here.
Yes.
Greer, can you tell us what I'm holding? It looks
Yes.
gross.
You're holding 1 liter of a phytoplankton. It's a small unicellular algae called Isochrysis gambiensis.
So it's a phytoplankton, so
Yes.
it's little tiny plants.
Yes.
Okay, fantastic. So what is the point? Is this something that they'll eat?
Yes, this is
Okay.
a very nutritious, very yummy algae that these guys will certainly eat. This particular algae species is cultured very heavily when working with bivalves and hatching them up. A very small cell, and so even the juveniles and the tiny developing larvae will be able to eat that algae.
That's awesome. Now, this is something that just exists out in the ocean naturally.
Correct.
Fantastic. So we're going to pour this in here,
Yep.
and what should we expect to happen?
That all of the algae would be filtered out, and we'll have this, basically this nice clear color here in several minutes.
Oh
Yeah.
man. All right. Are we ready?
Yes.
Okay.
Go ahead and pour it in. Woo! Yum, 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 yum. They love this.
Is that what they sound like?
That's exactly
Okay.
what they sound.
Assuming they don't clam up, right?
Yeah.
Awesome. All right. So that water looks gross.
Right.
And theoretically, it should be cleaned by how much time would this take? How much can they filter?
They can filter 5 gallons of water per day, this particular size group, yeah.
Now, moving on to our next quiz question, I want to talk about these shellfish anatomy a little bit more. So what do they use to filter this? What body part does a clam have in order to clean this water?
A siphon.
A siphon, perfect. So here is your next quiz question that is popping up. So a clam uses its siphon, but what is a siphon? Is it used for breathing, eating, or excreting? So answer on the little quiz question on your screen now. Fill in that poll and Greer will give you the answer in just a few moments. Now, while those tallies are coming in, we have that species of clam locally, right?
Yes.
Fantastic. And do we eat this clam? Because I do love my clam chowder.
You actually more likely are to find the northern quahog in your clam chowders and such. We do have northern quahogs living here in Florida and brought down through all of the clamming industry, but the northern quahog does better shelf life and is used more for human consumption.
Shelf life? I see what you did there. Very clever. All right, so I see that the polls are coming in, and it looks like
all of the above.
All the above. Fantastic. So is that correct?
That is
the correct answer?
Yes, absolutely.
So tell me more about this siphon. What is it?
Yeah. So the siphon, really basic tissue structure. That's kind of, there's these muscles inside of the shell.
Wait, I thought we were talking about clams, not mussels. Terrible. All right, sorry, keep going.
And the muscles sort of start flowing the water in one of the 2 tubes, because that's the siphon, is 2 tubes, brings the water in and then pushes it out. And while it's going through the siphons, it'll hit the gills so that the animal is able to breathe, to get its oxygen. It'll go through and allow it to get to the digestive tract so that it can eat. And it also helps push the poo out at the very end of the cycle. How to do it all.
That is so fantastic. So they eat and breathe all at the same time.
Right.
Pretty much like me, right?
Yeah.
And just shovel it in. I love it. Now, we got to see that clam, but I also see some clams that you've worked with previously in our touch pool right here that have some numbers on their shells. So tell us a little bit more about the numbers, the science you do in the field.
Right. Yes. So this clam has a number of numbers and letters on it that allow me to know exactly where it is in our quadratic system. So out in the bay, we have those 200,000 or so clams that Stephanie alluded to. And we have been doing projects on them to understand what benthic environments are really good for our clams to be living in, as well as can we put up some predator defenses to keep other organisms from eating them, because we want more of our southern quahog here in Sarasota Bay. And so that's why we released all of those clams within the last year and plan to do more of that with Sarasota Bay Watch here in the coming years.
That is so awesome. You are literally making a difference in our local environment. I love that. What a cool scientist. Now, clams seem like they're pretty well armored, that they have that really strong shell, but that's not the only animal we have here with a shell. So all the animals in our touch pool right here are invertebrates, but as Greer mentioned, they come in lots of different shapes and sizes. Let's focus on this giant shelled individual right over here.
Yes.
Who is this?
This is a lightning whelk. We see this often here in Sarasota Bay, and it's actually one of the more aggressive predators for our clam species. Yes.
What?
Yes.
That's ridiculous.
Right. So they can use their foot, that's this black part here, to kind of shuffle into the sand and find their clams, and then they'll actually pry the clam open with this little operculum. So operculum is a fancy word for covering. We see operculum in all kinds of animals. This operculum acts in a couple of different ways. I just mentioned that it can pry open its prey in terms of when it eats the clams. It has some sort of sharp edges on it for that. That can dig in there, and it uses the foot muscle to do that. It also, as you can see it right now, the foot is actually trying to sneak into this hole, and this operculum will be sort of a protective door to keep all of the mussel protected. So now it has all shell, all hard shell protecting it once it tucks itself underneath there and covers it with the operculum, that little hole.
That is the coolest thing. I would have never guessed that a snail could be a predator.
Right.
So that's pretty amazing that you're picking up this giant predator here. That proves you're pretty brave.
I am.
Now, I'm a little worried about this other guy that's creeping around in here. So just to celebrate Halloween and all of those creepy crawlies that are moving around down at the bottom of the ocean, there is this spooky looking, it looks like a football helmet with legs. What are we looking at here?
So here, this is a horseshoe crab.
Oh my gosh.
So yes, so the horseshoe crab, it does look a little creepy and crawly. It is one of the oldest animals here on Earth, older than dinosaurs. So that might be some of its creepiness. It's also closely related to spiders and scorpions, hence the creepy crawly features.
Perfect for Halloween.
Right.
I love it. So can we flip this guy over? I want to see.
Absolutely.
Oh my gosh, look at it. Whoa, that's ridiculous.
Right.
So aren't you nervous? I mean, that stinger, is it going to get you?
No, this is not a stinger. Actually, notice that it's starting to move this portion of it a lot more now that I have her upside down. She's trying to flip herself back over. That's all that particular piece is used for. One of the biggest features. Yeah.
That is the coolest thing. Okay, so this animal has been around longer than dinosaurs. It's related to spiders, so it's not a true crab then.
Right.
Oh, interesting. And it's not a stinger, it's more like a catapult, right?
Right.
To bounce it back over? Wow, that's amazing. Now, this can't hurt you at all, so if we see one that's flipped over on the beaches, we feel safe to flip it back over, right?
Yeah, that would be a nice thing to do.
Okay, fantastic. Now, I know that horseshoe crabs are pretty special in the biomedical industry as well.
Right.
So can you tell us, as a laboratory scientist, what is the purpose of a horseshoe crab in a human biomedical capacity?
Yeah, the blood is super valuable and used for different biomedical tests, I believe.
Cool.
Yeah, right.
That's amazing. And what color is that blood?
It's blue.
It's blue. Oh my gosh, how cool is that? All right, so you proved to me that snails can be predators. These creepy crawlies don't actually have to be predators. They're not actually scary. But we do have some predators that do live in here. So can you show us one of the apex predators or the top tier predators here in a touch pool?
Okay, so here we have...
So while Greer gets this predator all lined up, we're gonna show you what Greer does in the laboratory just on a daily basis. So can you walk us through what we're looking at right here?
Yeah, right here, those benthic sediment samples that I had talked about earlier from the living seawall. This is one of the hardworking students in my lab, and she's sorting through the sample and counting the number of tiny invertebrates found within the sample, helping us look at the diversity of what's living in the sediment as well as the quantity that's living in the sediment. Yeah.
Awesome. That's amazing. Now, looking at what you're holding here in this video, is that what the numbers on that clam
yes,
related to?
That's the quadrat that I was referring to earlier.
Sweet.
We put one clam per small section in there.
Amazing, which is the perfect transition because you were talking about that you need to see how many clams are in each individual square because a predator might eat them.
Right.
So what is a predator that might bother a clam?
Another predator that can bother a clam is the sea star that I have here. This guy, as you can see, has 5 arms. You guys are probably familiar with that, and it moves around. Oh, it moves around using these little tube feet, if you guys can see that. Those tiny little soft bubblies here. Yeah.
Well, that doesn't look like a very threatening animal. So how could it possibly hurt a hard-shelled clam?
Right. So the sea star here will actually come up and with a lot of patience and time, it can take a while, can actually pry open the clam. If it was closed like this, the little tube feet can hold on to it and keep pushing water through the tube feet to allow it to kind of build up pressure, keep pushing, keep pulling, and eventually open the clam. Then the sea star does something wretched. It pushes out its stomach.
What?
Yeah.
Get out of here.
Yeah, it's foul. And eats the clam from there, from the outside of its body, and pulls it back in.
No way.
Yeah.
So perfect horror story for Halloween.
Yes,
That's amazing.
absolutely.
So not only is a sea star a jet-propelled animal that uses water to move, but it also can shoot its stomach out of its body to eat its food.
Yes.
Oh my gosh, that's ridiculous. Now, unfortunately, we are starting to run out of time, so I do want to go back to our original clam experiment.
Yes.
So can we see, Greer, how much that dirty algae green water is now clean?
Yes.
Awesome.
This will be fun.
All right, while Greer grabs, oh my gosh, it looks so clear. This is ridiculous. So while Greer grabs this clam water, get ready, your mind is going to be blown.
Here we go.
Look at that. What? That's
They eat a lot.
amazing.
Yeah.
So these clams actually clean this water. That's ridiculous. So this proves that this is science in action.
Yep.
This is what you do on a daily basis. Now, clams, obviously you're doing the quadrants with those little square boxes. You want to monitor them, you want to protect them, but they seem pretty hardy. Do we have any reason to worry about their populations?
Absolutely. So bivalves, both the scallops are another organism that I work with, as well as these clam species, really are important in terms of water quality and feeding our other organisms. Very important here in Sarasota Bay.
That's amazing. I mean, this proves that they are really important filter feeders.
Yes.
Using that siphon, that fancy vocab word we learned earlier. Now, Greer, you were absolutely amazing. We're going to round of applause for you.
Thank you.
I learned so much all about all your spineless friends,
Yes.
right? Spineless science, I love it. Now, we're going to actually get a little sneak peek into our guest scientist for next week. So we are going to move to questions really quick, and then we're going to meet our guest scientist. So one of our questions that just popped up was, let's see, how long does it take for the water to get cleaned? So
Right.
This happens so fast.
Right. This can happen anywhere from a few minutes if they're clamming up, as you referred to earlier, and their siphons aren't out. It might take a couple of hours, but these guys can go ahead and filter about 5 gallons per day.
That's
This
amazing. Now, I heard a red tide question as well. So here in Florida, red tide is a toxic algae that blooms off the shore. So can they eat that? Does it make them toxic? What's the deal?
They do eat the red tide. We found that the southern quahog actually can kind of lay dormant and not eat quite as much to keep itself when they notice that there's lots of red tide. But there are certain times of year when those red tide peaks that the state will not advise anyone to take
Right.
any sort of bivalve, because they do take in any algae, and that toxin can add up in their tissues and be toxic for you and any other consumers.
Wow, that's really good to know. So we are starting to wind down. Do we have any last questions before we meet our scientist for next week? Oh, perfect. All right, so the last question I think we have time for is talking about sea urchins. So we actually have one right here. So Greer, can you tell us a little bit more about this guy?
Yes, so sea urchins are an invertebrate, and they are really close cousins with the sea star. It's kind of trickier to see, but they do have this sort of radial symmetry where it radiates from a center point. They do have tube feet. So they are invertebrates indeed, and they are echinoderms, or in the same group as sea stars.
Well, clearly the good looks run in the family, right?
Yeah.
Yeah. Absolutely. Any last minute questions before we move on? So nothing looks like it's come into the chat box, so perfect timing. Oh my gosh, Greer, that was amazing. We learned so much. Sea stars, sea urchins, all your amazing clam work. Thank you for not being shellfish and sharing all this information with us. Now, in the meantime, we're actually going to jump over and meet our next scientist for the day. So we're going to queue up that promo for next week and give you a little teaser of who to expect.
Production of Mote Marine Laboratory. The Mote SEA Show on SeaTrek.tv. Coming up next, Sharks and Rays, November 5th, 2019 at 9 o'clock a.m. Eastern. Mote Science Education Aquarium Show. Your host, Ross Johnston. News with Stephanie Kettle. STEM expert, Valerie Hagen. This program is partially supported through funding from the Rob and Melanie Walton Foundation. Thank you. The Mote SEA Show, Science, Education, Aquarium.
All right, so getting ready for World Skype Day, the World Skype-a-thon, we have this jawsome celebrity who is going to teach us all about sharks and rays. This is Valerie Hagen, a Mote Marine Laboratory shark biologist. Oh my gosh, what are you going to be teaching us next week?
All right, well, here at Mote, I work in sharks and rays research conservation. So we're going to be looking at both sharks and rays, which are a lot more closely related than most of people might think. They're in the same grouping. They're basically cousins.
Wow, that's going to be so amazing. So we're going to learn about their biology, tracking, tagging, monitoring, and what makes these amazing fish, like the ones we have over here, so fantastic.
Well, if you ask me, it's absolutely everything. But they are extremely important to our ecosystems and the balance of the entire food web. They keep everything underneath them in the food web in check, so the health of our entire ocean ecosystem and land ecosystem actually do depend on sharks and rays.
And it's a great transition from today because the stingrays that we'll be meeting next week, they actually eat the invertebrates that we met today. So we're just working our way up the food web.
Absolutely.
Now, just to last minute plug this, we want to make sure that next week's program is exclusively used by Skype. So I want to let all the teachers and viewers out there that next week's shark program is just on the Skype platform. Now, for anyone else who also wants to reach out and ask our amazing scientists any ocean questions, please go to www.seatrek.tv/ask for our Flipgrid page. Now, Flipgrid is a really awesome video voicemail service. It's completely free, and any of you students or adults out there that have any ocean science questions can leave us a free video question, and we will respond with a personalized video answer. So it's a great way for us to be your video pen pals and be your ocean experts whenever you have any questions. So thank you again for joining us for the Mote SEA Show. Once again, my name is Ross. Tune in next week for Valerie. Let's say goodbye to Greer right over here. And we hope that you tune in next week for our amazing program on sharks and rays. And thanks for enjoying our program on invertebrates. Happy Halloween, and tune in next week. Bye, everyone.